Hi guys, this is Caitlyn again with Star Tutors. So I just took the 2012 AP Calc BC multiple choice no calculator test.
That's a mouthful.
That's a mouthful right there. So now I'm going to go through the other multiple choice section, which is calculator. So I have my graphing calculator here. It's 50 minutes, 17 questions. So just a reminder, if you haven't seen the other video, go and watch the no calculator section, multiple choice. I ended up getting, there was 28 problems on that. I got 24 out of 28. I'll note that I attempted 2 problems and totally just did them wrong. So no, it's okay to not get every single question right. And 2 of them I didn't even have time to do. So we're at 24 out of 28 right now. That's my current score. This has 17 more problems, so we got a total of 45 problems. My goal score right now is going to be to get a 30 out of 45. So remember, again, on this test, the multiple choice is worth 50% of the test. The other 50% is the free response questions. And you don't need you don't need to get 45 out of 45 to get a 5. In fact, if I got a 30 out of 45 on these multiple choice and I get 5 out of 9s on all of my free response questions, that would be a 5. So I'm shooting for 30, which means I only really need to get 6 more questions right. All the other ones are going to be bonus. I'm going to try to make it so that I do the easier questions first, and then I'll go and do the harder questions. But again, this is 2012 AP Calc BC calculator section, multiple choice. And I have a timer. We've got 50 minutes. Someone else is also timing to check to make sure that's good. And we're going to get started. Ready, set, go. All right. The function f, whose graph is shown above, is defined on the interval -2 to 2. Which of the following statements about f is false? Switch to red. Which of the following statements is false? Okay. I'm going to go through each of them and mark them wrong if they're true. So f of x is continuous at x equals 0. That's true. I can draw the graph of f without picking up my pencil. F is differentiable at x equals 0. That one might be false because it looks like at 0 the slope on one side doesn't look like the same as the slope on the other side at this point at 0. So I think that one is probably false, but I'll check the other ones. F has a critical point at x equals 0. F has an absolute, well, it does because it's a minimum there, so that one's true. F has an absolute minimum at x equals 0, since it's only defined at -2 to 2, and that's the lowest point, that's true. The concavity of f changes at x equals 0. It does look like it goes from concave down to concave up, so that one's also true, so yes, it's going to be B here. So it's not differentiable because the slopes on either side of 0 are different. Okay, notice I didn't need a calculator there. 77. Let f and g be the functions defined by e to the x and x to the 4th. On what intervals is the rate of change of f greater than the rate of change of g? Okay, so rate of change of f, that just means the derivative, f prime. So I'm looking for f prime of x is greater than, bigger than, rate of change of g, g prime of x. So I want to know, where is f prime of x bigger than g prime of x? So the derivative of f of x, the derivative of e to the x, is just e to the x. And the derivative of g of x is 4x cubed. So I'm looking for where e to the x is bigger than 4x cubed. And so you could graph both of these functions and look at them on your calculator and find where the one is bigger than the other. I'm going to recommend here instead graphing the function on your graphing calculator e to the x minus 4x cubed and seeing where that is positive. We want to know where it's bigger than 0. It's easier to identify where some function is bigger than 0 than it is to identify where one function is above another function. So I'm going to go on my graphing calculator, go to graph, and plug in the function e to the x minus 4x cubed. Give me a second because this takes a minute. E to the x minus, oh my gosh, we'll see if I can get my calculator. minus 4x cubed, 4x raised to the third. Great. Okay, so I'll roughly draw what I get. Something that looks like this, down and up. Great. I want to know where this function's positive, so I'm looking at, well, it looks like it's positive everywhere except between here and here. So I'm going to find those points. So analyze graph. I want to find a 0. I want to find a 0. You know, you got to give it the left bound and the right bound, the lower bound, and oh my gosh, I keep pushing the wrong button. This is a struggle. Lower bound. Great. Okay, so it says that this first 0 is at 0.831 roughly, and then I'm going to find the other one is at 7.384. Again, I'm looking for where this function's positive, so that's everywhere before 8.31, negative infinity to 8.31, and everywhere after 7.384. So that's going to be B. Okay. 78. So we're already 2 questions in. We only need 4 more. That's good. And we still have 45 minutes. The graph of the piecewise linear function f is shown above. What is the value of the integral of this? Okay. Cool. Oh, so here we want to find, you could graph this function, this 3f of x plus 2, based off of the graph of f, but I think that's going to be harder. Instead, we want to use rules of integrals that we can split everything up. So I'm going to split this up, this 3f of x plus 2 dx. First, I'm going to split it into 2 integrals, the sum of 2 integrals. So negative 1 to 9 of 3f of x dx plus the integral from negative 1 to 9 of 2 dx. And then I'm going to take the 3 out of the first integral, since that's a constant. So I have 3 times the integral from negative 1 to 9 of f of x dx plus, and then I can just evaluate this. So the integral of 2 is 2x. I evaluate that from negative 1 to 9. Okay, so now this integral from negative 1 to 9 of f of x dx is just the area under the curve that I'm given. So I want to find the area under this curve. So I'm going to split it up into a bunch of different things that I can find the areas of. Sorry, I'm going to do this triangle. And, well, I guess I can just do the whole big triangle. That would be easier. So the area from negative 1 to 3 is going to be negative since it's below the x-axis. And it's like a rectangle plus a triangle. So the first rectangle looks like it has width 1, 2, 3 and height 1. So that's 3 times 1, 3. And then this triangle is 1/2 of 1 times 1, so it's 1/2. So I have negative 3.5 for that first area. And then the rest of the area above the x-axis goes from 3 to 9. So the base of that triangle is 6. And the height of the triangle is 2. So this 1/2, 6 times 2, which is 6. So my area there is 6 minus 3.5, which is 2.5? Yeah, 2.5. So this part here is 2.5. So now my answer is going to be 3 times 2.5 plus, I plug in 9 and I get 18, and then I subtract when I plug in negative 1, which is subtracting negative 2. So be careful with negatives. 2.5 times 3. You know, I can probably multiply 2.5 times 3 by myself, but now I have a calculator, so I can be sure that I don't make a mistake and get 7.5. And then I want to add 18 times 2, which is 36. So I add 36, 43.5. That's not an answer. Ruh-roh. Okay. I must have multiplied something wrong. So let's see. 18 Is it? It is supposed to be 18. Oh, it's not times. Guys, see? Okay, here we go. I don't know how to add. 18 plus 2 is 20. All right, we get 27.5. That's an answer. There we go. Good. All right, I'm glad 43.5 wasn't an answer because I would have picked it. Okay, which would have been okay because, you know, you make mistakes sometimes. All right, 79. Let f be a function having derivatives of all orders for x positive such that f of 3 is 2, f of prime of 3 is... Okay, which of the following is the third degree Taylor polynomial for f about x equals 3? All right, so this is a BC question because it's about Taylor series, or Taylor polynomials. And this is something you have to remember the definition of the Taylor series and then the definition of the Taylor polynomial, which maybe you do, and if you do, it's not going to be a very difficult question, but if you don't, then you should skip it. So for now, I'm going to skip it because there's going to be easier questions on here than that one. So let's skip it for now. We'll come back to it. 79. Okay. 80. The graph of f prime, the derivative of f, is shown above. Which of the following statements must be true? These ones are always good. All right, so let's go through each of the questions and see which ones are true. F has, okay, so this is the graph of f prime. F has a relative minimum at x equals 3. X equals negative 3, sorry. So in order for a function to have a relative minimum, it needs to have its derivative needs to be 0, right? And it needs, so a relative minimum would look like this. So its derivative there would be 0, and it would have to be concave up. So that means I need my derivative, f prime of x, to be 0, and I need the second derivative, which tells me about concavity, to be positive. This is at negative 3. So here I have that my derivative is 0. That's good. And then the second derivative will be the slope of the first derivative. The slope of this graph is positive. So this one's true. 1 is true. Okay, so that means I can get rid of B and C. So now it's either 1 and 2 or 1 and 3, so I only need to check one of them. 2 says the graph of f has a point of inflection. Oh, actually I need to check both. Well, we'll see. The graph of f has a point of inflection at x equals negative 2. And the third one says the graph of f is concave down from 0 to 4. I'm going to check 3 first. So graph of f concave down, that would mean that f double prime of x, so the second derivative, would have to be negative for those x's, which would mean that the slope of the first derivative, which is the one that I see, would need to be negative. So from 0 to 4, the slope of the function that we're given, of f prime, looks negative. So I'm going to say that one's true. True. So 1 and 3 are true, so it must be E. Yeah, okay. So I don't even have to think about 2. Although I will say a point of inflection is a place where the concavity changes. So it goes from concave up to concave down. And at negative 2, yeah, it's not, graph of f is a point of inflection. Concave, the graph of f would have to, so it looks like f prime is going from concave down to concave up. But that doesn't tell us anything about the original function having a point of inflection there. I'm going to stick with my answer E. I believe that's right. 81 is that, let's see, let f be a function that's twice differentiable. So that means I could take 2 derivatives on negative 2 to 2 and satisfies the conditions in the table above. Okay, so they're telling me a bunch of things about which things are positive and negative. F of x equals f of negative x. So if you remember, guys, this means that the function is even. So I'm going to draw a picture to guess. It means that if I plug in an x value, it's this. I get the same thing if I plugged in the negative of that value. So like these points have to be the same, and these points would have to be the same. So that means it's an even function. what are the x-coordinates of the points of inflection of the graph of f? So again, points of inflection mean changes in concavity. That means the second derivative, f double prime of x, is changing sign. So it's going from positive to negative or negative to positive. Okay, so let's think about that. So it says that the second derivative is negative from 0 to 1, and it's positive from 1 to 2. So the only place that it could potentially change sign, oh, okay, see, this is fun. So between 0 and 2, it looks like the only place where the second derivative changes sign is at x equals 1. But we have to use the fact that it's even. So that tells me that when it does it positive 1, it also does it negative 1. So that means at negative 1, we're also going to have this switch in concavity. So, but notice, look, they gave us b as an answer, x equals 1 only. And if you didn't remember to use the part that it was an even function, you would probably pick that one. But I believe the answer is D, because it does the same thing on from 0 to 2 as it does on negative 2 to 0. It kind of like you can reflect it across that y-axis, and it'll be doing the same thing. Okay, so yeah, I believe that's D. Great. Okay. What is the average value? Ooh, do I remember the average value? I think I do. Okay, so again, this is average value. You have to remember the equation for that. So the average value of a function is going to be on an interval 1 over b minus a times the integral from a to b of that function. So this is the average value of the function f on the interval a to b. So here I have a is 0 and b is pi over 2, and my f of x is my y, the square root of cosine of x. So I'm trying to find 1 over pi over 2 minus 0, integral from 0 to pi over 2 of the square root of cosine of x dx. Oh, and so I just looked at this and I was like, I don't know how to integrate the square root of cosine of x. But luckily, my calculator does. So I'm going to use my calculator, plug this in. So I've got the integral from 0 to pi over 2, of the square root of cosine of x dx. My calculator tells me that that integral is 1.198 approximately. So I've got 1 over pi over 2 times 1.198. So this, flip this, this is 2 times 1.198 over pi. I'll ask my calculator what that is. So times 2, divide by pi. And it tells me it's 0.7628, which is approximately 0.763, which is C. Cool. 83. If the function f is continuous at x equals 3, which of the following must be true? Okay, so they're not giving us a ton of information here. Let's remember what it means for a function to be continuous at x equals 3. That means quite a few things. First of all, it means that the value of the function at 3, so f of 3, has to be equal to the limit of the function as x approaches 3. That's what it means to be continuous at 3. But in order for the limit of the function at x equals 3 to even exist, we need both the right-hand limit and the left-hand limit to exist and be equal. So this limit as x goes to 3 has to be the same as the limit as x goes to 3 from the right, or and that has to be the same as the limit as x goes to 3 from the left. So there's a lot going on when you just say a function's continuous at a point. It means quite a few things. So now let's go through these and see. So A says f of 3 is less than the limit as x goes to 3 of the function. That's not true. I said it has to be equal. B says that the left-hand limit is not equal to the right-hand limit. That can't be true because those limits have to be the same in order for the function to have a limit there. C says that f of 3 is equal to the left-hand limit is equal to the right-hand limit. Yes, that's going to be the answer. D and E tell us something about the derivative, but just because a function is continuous doesn't mean that it's differentiable. So we know nothing about whether this function even has a derivative at x equals 3. So we can't say anything about it, which is why those ones are not right. Okay, 84. Oh, this looks good. Let f be the function with first derivative given by that. I'm not even going to say that. Which of the following are all intervals on which the graph of f is concave down? Okay. Concave down means what? Again, that means the second derivative of the function has to be negative. Okay, so I need to take the derivative of this function. So to find f double prime of x. So let's do that over here because I think it's going to be a lot of work. So f double prime of x equals the derivative with respect to x of e raised to this x to the fourth minus 2x squared plus 1 minus 2. Okay, so I differentiate e, and when you do that, you just get e raised to the same thing, but then you have to remember chain rule. So I have to remember to multiply by the derivative of that exponent, which is going to be 4x cubed minus 4x plus 0. And then the derivative of negative 2 is just 0. So this is my second derivative. Lovely. And I'm looking for where this function is negative. So I'm going to plug this function in exactly like this into my calculator and then try and find where it's below the x-axis. Between negative 1.5 and 1.5. That's also important. So, okay, go to my calculator, go to my function, I want to graph different functions. So I've got e raised to the x, e raised to the x to the fourth minus 2x squared plus 1. Oh, be really careful when you're plugging this stuff in, guys. I just typed it in wrong, so you don't want to lose a point because you typed something in wrong. Times 4x raised to the third minus 4x. Okay. All right, and I'm looking between, I'm going to change my window so that I'm not distracted by all the other stuff. We got negative 1.5 on x to positive 1.5. Okay, great. So the function that I get when I graph it looks like this. It goes like up, and then it goes through 0, and then it goes down. It almost looks like a cosine. But I guess it looks like a cubic. That makes sense, kind of. Okay. Great. And I want to know where this function's negative. So I'm looking from whatever this point is to negative 1.5, and from 0 to whatever this point is. So I need to find those zeros. So I will do that. Find the zeros of this function. So the 0 on the left side says it's negative 1. That's convenient. So we've got negative 1.5 to negative 1. And the other interval looks like 0 to 1. 0 to 1. Okay, so hopefully there's an answer that says, yep, there is D. Okay, 27 minutes left. So I think we're doing pretty good. 85. The fuel consumption of a car in miles per gallon is modeled by this, where S is the speed of the car in miles per hour. If the car is traveling at 50 miles per hour and its speed is changing at the rate of 20 miles per hour squared, what is the rate at which its fuel consumption is changing? That's a lot of words. I think I'm just going to skip this problem. I don't know. That was just too much. I don't feel like doing that today. We're going to move on. Do something else. Okay. 86. The derivative of the function is positive for all real numbers x, and the integral from 4 to 7 of f of t is 0. Which of the following could be a table of values for the function f? Okay. So its derivative being positive, that tells me that the function is always increasing. So remember, the derivative of the function is positive, means that the function itself, f of x, is increasing. Then they also tell us that this integral from 4 to 7 of the function is 0. So the function's increasing, but the area under the curve from 4 to 7 is 0. Well, that tells me that it must, let's just try and sketch some random picture of this function from 4 to 7. If it's increasing and its area under the curve is 0, then I must have some negative area and then some positive areas that are like canceling. So I must have some function that looks like this between 4 and 7. So I'm going to go through the table and see which of those things, which one looks like that. So in particular, it's got to hit 0 since it's continuous. I assume it's continuous. Yeah. Somewhere between there. So which one could be? Let's see. Since its derivative, it's gotta be increasing. So d is not increasing. That's just a constant 0. That's not increasing. So not d. E would just always be positive. Would have positive integrals. So it's not e. C would goes from -4 and then 6 and then 3. That wouldn't always be increasing since it dropped from 6 to 3 here. So that one doesn't work. And A would always be negative, which would have negative integral. So it's got to be B, which goes from negative to positive. Its values are increasing, and it has some negative and then some positive. So yeah, it's got to be B. Okay. 87. Let R be the region in the first quadrant bounded by this graph. R is the solid of a base. Ugh, okay, this is a volume question. I don't like volume questions, so I'm going to skip it. 88. The derivative of a function f is increasing for x less than 0, decreasing for x bigger than 0. Which of the following could be the graph of f? Okay, see, this one seems a lot more approachable. So it's increasing it. So, and we want this to be the graph of f. The derivative, read. The derivative of f is increasing. So f prime of x is increasing. Okay, f prime of x increasing tells me that its derivative is positive. So that tells me f double prime of x is positive, which means the function, so that means that the function f of x is concave up. Concave up. That's tricky. For x less than 0. So for x less than 0, my function should be concave up. Similarly, it says the derivative of the function f, so f prime of x, is decreasing for x bigger than 0. Decreasing. Sorry for the poor handwriting here. That means if f prime of x is decreasing, that means its derivative, the second derivative, is negative, which means that f is concave down for x is positive. So which of these graphs now is concave up for negative x's and concave down for positive x's? Let's see. Well, it's not A because that's concave up the whole time, and B is concave down the whole time. C goes from concave down to concave up, which is not what I want. E goes from concave up to concave down, which is what I want. So yes, it's E. All right, so that was really tricky though. I almost fell into the trap of doing that wrong. I had to focus on it saying the derivative of the function f is increasing and decreasing. If I had done this problem just thinking that it meant f is increasing and f is decreasing, I would have gotten a different answer. All right, let's keep going. 89. A particle moves along a line so that its acceleration for time bigger than or equal to 0 is given by a of t equals this. If the particle's velocity at t equals 0 is 5, what's the velocity of the particle at t equals 3? Okay, yeah, so this one, they're telling us, so they tell us the acceleration. They want us to know something about the velocity. So here we have to remember the relationship between the velocity of a function and the velocity and the acceleration. So we need to remember that the derivative with respect to time of the velocity, which you might write as like v prime of t, is the acceleration. So we want to use that relationship. So this is going to be, we're going to use the fundamental theorem of calculus here. The fundamental theorem of calculus, again, it relates a function to its derivative via the integral. So it says the integral of a function, let's say the integral of the function's derivative from a to b is equal to the function f of b minus f. It's equal to f of b minus f of a. So in this case, we're applying this where our derivative function is the acceleration, and our original function is the velocity. So here we have the integral, and how do I know what to plug in for a and b? Well, they tell me something about time 0, and they want me to know something about time 3. So that means I should plug in 0 and 3 for a and b. So I have the integral from 0 to 3 of my acceleration, which remember is v prime of t, is going to be equal to v of 3 minus v of 0 by this fundamental theorem of calculus. And I'm trying to find the velocity at time 3, so I want to find v of 3. And they tell me that v of 0 is 5. This is 5. So now I know that v of 3, if I just add that 5 to the other side, is equal to 5 plus the integral from 0 to 3 of a of t dt. So what I'm going to do is I'm going to plug the expression for a of t into my calculator and find the integral from 0 to 3 of that, which will give me some number. I'll add it to 5. That should be the answer. So let's do that. Let's see. We've got the integral. So remember guys, it doesn't matter what your variable is, what you call it. So here it's called t, but on your calculator it's probably called x. It doesn't matter. We can exchange our t's for x's as long as we're consistent, and it will be fine. Again, always be careful when you plug this stuff in. Okay, my calculator tells me that that integral is 6.71 roughly. So I've got 5 plus 6.71, so 11.71, which is E. Cool. All right, we got 17 minutes left, and there's 3 problems that I haven't looked at yet. and then there's a couple that I skipped. But at this point, I'm doing pretty good, I think. It's possible I've made some silly mistakes, but so far I feel like this has gone better than the no calculator section. And there's been actually a lot of problems that are more conceptual instead of as computational. Okay, let's do 90. If the series this converges and a sub n is bigger than 0 for all n, which of the following must be true? So again, this is a BC topic. We're talking about infinite series here. We know it converges and it's always positive. Which of the following must be true? Okay. So the first one, this first limit, is the thing that you find when you're using the ratio test. It's like, I often call it L. And the ratio test says that L needs to be less than 1 in order for your series to converge. But it doesn't need to be equal to 0. So we know that this limit is going to be less than 1 since it converges and it's positive. But we don't know that it's 0. So A, I don't think doesn't have to be true. B, the absolute value of a sub n has to be less than 1 for all n. I don't think that doesn't sound true, but we'll see. The sum is 0. Okay, the only way for the sum can't be 0 because it tells me all of the terms are positive. I'm adding up a bunch of numbers that are all positive, and if you add up a bunch of positive numbers, you can't get 0. So that doesn't make sense. D, n times a sub n diverges. E, a sub n over, whoa, okay. A sub n, okay, so I think, interesting. Yeah, this one's tricky. The limit of this goes to 0, that goes to... Okay, so for now I'm going to skip this one because at this point these are kind of hard. And I'm going to try and do the last two problems first before coming back to this one. 91. Oh man, polar stuff is... Here we go. The figure above shows the graphs of the polar curves, this and this. What's the sum of the areas of the shaded regions? Yeah, we're not going to do that one right now. Polar coordinates kind of scare me, not going to lie. I just don't work with them a lot, and they're kind of weird. All right, 92. The function f is differentiable for all values of x. H of x is equal to h of 2 minus x. Interesting. Which of the following statements must be true? Okay. So it's differentiable, so I know its derivative exists. I'm going to note that, that means I can take a derivative. So if I take the derivative of both sides of this equation, h of x equals h of 2 minus x, on the left side I'll just get h prime of x. On the right side, I'll get h prime of 2 minus x times the derivative. I have to do chain rule. So I'd have to do the derivative of 2 minus x, which is negative 1. So I know h prime of x is equal to negative h prime of 2 minus x. I don't know if that's going to help me yet, but it's something that I know. Let's see. So, let's plug in 0 to see this. This third one looks similar, I guess. So if I plug in 0, I get h prime of 0 is negative h prime of 2. Yeah, I think I did that right. That's not true then. So I can't have h prime of 0 be equal to h prime of 2 equal to 1, because that would say 1 equals negative 1, which wouldn't make sense. So I think 3 is not true. So I think C is wrong, D is wrong, and E is wrong. So that means it's either 1 or 2. So 2 says h prime of 1 is 0. So if I plug in h prime of 1, I get h prime of 1 is equal to negative h prime of 2 minus 1, which tells me h prime of 1 is equal to negative h prime of 1. The only way I can have a number equal to the negative of itself is if that number is 0. So yeah, h prime of 1 must be 0. Alright, so I think 2 is the only one that's got to be the only one that's right. So it's B. Okay, so now that's, alright, we've seen all the questions, so that's good. We still have 11 minutes left, so I'm going to go back to some of those other ones. I'm still not going to do this polar coordinate one, because I just don't like polar coordinates. Let's go back up to the first one that I skipped, which I think might be this one, 85. Cool. Fuel consumption of a car is modeled by this, where S is the speed of the car in miles per hour. If the car is traveling 50 miles per hour, it's speed. Be careful there, it's talking about speed rather than velocity. You want to pay attention. They're different. So speed is the absolute value of the velocity. Velocity tells you if you're going right or left, but the speed tells you whether you're moving. Your speed is the absolute value of the velocity. It's always positive. Okay. Its speed is changing at the rate of 20 miles per hour. What's the rate at which its fuel consumption is changing? Rate at which its fuel consumption is changing. So fuel consumption is this big F. If I'm asking for a rate, then I need the derivative of that. So I want the derivative F prime of little s. And I want to know what this is when the car is traveling 50 miles per hour and its speed is changing at 20 miles per hour squared. Alright, so let's first start out by, so I want F prime of s when car is traveling 50 miles per hour, so the speed is s, speed is 50 miles per hour, and the speed is changing, so that means like the ds dt, oh, see, they're tricky with this language here, 20 miles per hour squared. I think what I said before about speed and velocity is not actually going to be relevant in this problem, but in other problems it often is. So let's take the derivative of this. Let's take the derivative of this function. It's not going to be super pretty, but it'll be okay. You could do this on your calculator if you wanted to, but I'm just going to do it by hand. So 6 times, when you take the derivative of e, it's just e to the stuff, and then you have to remember chain rule. X squared over 2400 times chain rule. So now I need the derivative. S is a speed, it's a function of time. Derivative with respect to time. Oh yeah, this. Yes, I'm taking the derivative with respect to time here, everyone. This is a tricky problem. Derivative with respect to time of f of s. So note that the speed is dependent on time, and I'm taking the derivative here with respect to time, not with respect to the speed. That's important. So I'm taking the derivative with respect to time of this s over 20 minus s squared over 2. Okay, so now I have 6 times e raised to this s over 20 minus s squared over 2400. The derivative of s over 20 is just going to be 1 over 20 times the derivative of s with respect to time. Again, remember, s is a function of t. And then the next derivative of negative s squared over 2400, well, I'll bring down the 2, and I'll get 2 over 2400. That's 1 over 1200 times s times ds dt. Yeah, that's right, I think. All right, and then they tell me that ds dt is 20, so I'm going to plug that in, and that s is 50. Notice I needed both pieces of information there. So if you were trying to do this problem but you didn't actually end up using that ds dt was 20, then you're not using all the information they're giving you, and you probably have made a mistake. So let's plug everything in. So we have 6, then we have e raised to the 50 over 20 minus 50 squared over 2,400 times 1 over 20 times 20 minus 1 over 1,200 times 50 times 20. Okay, thank goodness we have a calculator. We can plug everything in there. Also, we've got just over 6 minutes, so 6 times e to the 50 over 20 is 5 over 2 minus 50 squared divided by 2,400. And then I'm multiplying that by 1 minus 50 times 20, 50 times 20 divided by 1,200. Okay. My calculator says that that is 4.299 miles per gallon per hour. Alright, that was hard. B. Okay, so we got a little bit over 5 minutes left. We're definitely not going to have time to solve all the rest of the problems, but that's okay. I've taken my time. I've done the ones that I knew or had at least a way to start how to do. And the whatever ones I have left, I'm going to guess because there's no guessing penalty. Let's see if we can do like one more. Okay, I'll do this. I'm going to do this volume one rather than do that polar coordinate one. So we've got a region R in the first quadrant bounded by this function. So you could graph that function. Natural log of 3 minus x. That's going to be reflected x shifted. Oh, that's tricky. Yeah. Okay, I'm going to graph it. I was going to try and do it in my head, but, you know, under pressure, I don't think I can do that. So, let's see. Clear this. So we've got natural log of 3 minus x. 3 minus x. Great. We're looking for between 0 and 2. Yeah, x between 0 and 2. Okay, so it looks like this. Between 0 and 2. And it looks like, let's see, 5. I'm just changing my window so I have a better view of it. Yeah, so it looks like it crosses at 2. Yeah, so if you plug in 2, you get natural log of 1, which is 0. So it does cross here at 2. So this is our region. So this bounded above by this graph, and it's in the first quadrant. So we're just looking at this. This is our R that I've shaded here. R is the base of a solid for which each cross-section is perpendicular to the x-axis is a square. Perpendicular to the x-axis is a square. So the base of each thing has is going to be a square, and we need to know what the length of each of those sides is. So, well, if I give you an x value between 0 and 2, then the height of the side length of the square is going to be the length of the bar that I've drawn here, which is just up to the y value, where here the y value is going to be natural log of 3 minus x. So my side lengths are natural log of 3 minus x for whatever x I'm picking. So my volume of this solid is going to be the integral from 0 to 2 of, I want to add up all of the areas of all of the cross sections for each x. And the area for each cross section is the area of this square, which is natural log of 3 minus x all squared dx. And so now I'm going to plug that into my calculator. So I've got the integral from 0 to 2 of natural log of 3 minus x all squared dx. x, which is 1.029. 1.029 b. All right, at this point I have less than 2 minutes left, so I'm going to have to guess on the last ones, which is totally fine. Again, remember, you don't need to get a perfect score on this. This 90, so I have a feeling it's E. I've done a lot of Calc 2 stuff, so I think it's going to be this one. I'm not, so my justification for that is that if you're like D is a thing that's going to be bigger as, like the terms are going to be a lot bigger. As I'm multiplying by n, I'm multiplying like 1, 2, 3, 4, 5, getting bigger and bigger and bigger. I guess it could be that that diverges, but if I'm dividing by something, I'm making my overall thing smaller. So these terms an over n are smaller than this an, which already converges. So that's why I think the smaller thing also converges by like the comparison test. So that's why I'm picking E there. And then I got 50 seconds. Yeah, this polar one we're not even going to attempt. I don't know, which one looks good? The figure above shows that R is 2, so that means that this is 2. So I could at least estimate, like the circle has, you know, area pi r squared, so that's 4 pi, right, is the whole area. So it should be something less than 4 pi. And 4 times pi is 12.57, so something less than 12.57. So I'm gonna guess C, 8.5. I think it's either C or D based off of that. Look at that, I didn't do any math, I just found the area of a circle. And then I got that one. Okay, we got 5 seconds left. Yeah, cool. Now I'm gonna see, there goes my timer. Great. And I'm gonna get the answers up now and see how we did. Go back up to the top. Here we go. Notice that a lot of those problems didn't even use the calculator. You know, one way you could go about this test and saving some time if you're stressed on time is just doing the problems that don't involve the calculator first, and then do the ones that do. Oh, I totally forgot this problem. No, that's fine. We missed one. I should have gone back to that. Okay, 76. So again, I'll do this in green. 76. I got B. The answer is B. Great. 77, B. Good. 78, C. Great. 79, I was silly and I forgot to guess. So go back and make sure you answer all the questions. If I had my bubble sheet, I like to think it'd be different, but you never know. 80 is E. Yep, that's what I got. 81, D. Good. 82 is C. Great. 83, also C. Yeah, knowing the definition of being continuous. It's really important to know all of those definitions. It might seem silly to have to remember all of them, but it's really important. 84, D. Good. 85. That one was tricky. 85, B. Sorry, I misread the thing. B. Did get that right. Great. 86 is also B. 87 is also B. Let's see. Yep. Oh, that's the one I just did. Yeah. This was actually not too bad of a volume question. Sometimes the volume questions, though, can take a long time to just even set up. 88 is E. That one was tricky because you had to remember that it was the derivative of the function f. They like purposely didn't say f prime of x. 89 is E, and 90 is E. Yeah, see, my intuition was right there. But even if you didn't, even eliminating 2 answers and then guessing on the other 3 would have been good. 91 is D. Okay, so I guessed wrong there. 91 is D. But I narrowed it down to 2 choices by just knowing the area of a circle, so that was good. And 92 is B. Great. All right, so it looks like I only missed 2 problems. So that puts me at, out of these ones, 15 out of 17 on the calculator. So that means total I've got 25 4 plus 15, which is 39? 39 out of 45.
Okay, then that means you only have to average 3 out of 9.
I only have to average a 3 out of 9 on each of the free response questions in order to get a perfect score, number 5 on this AP test. So that's great. I hope this was helpful going through the multiple choice questions of this 2012 AP Calc BC exam. And yeah, best of luck studying.